All right, so in the last session we we calculated some frequencies of our data, try and get a frequency distribution, but it's a little bit more useful to display things visually. So we're going to construct histograms. We're going to take those frequencies and draw bars of height that matches the frequencies that we see in our data. Now what we're hoping to see quite often is a nice bell curve type of shape. So this would imply your data comes from a normal distribution. But there's other distributions that you can get as well. So you can get data that's pretty much the same all the way across. That is, it looks like it's even or a uniform distribution. You can sometimes get things with a little bit of what's called a tail, or skewed to the right or skewed to the left. So this is sort of like a normal curve, except you have one tail that sticks out to the right or to the left. Now if it's skewed right or skewed left, the skew is where the tail is. So this is skewed right. This kind of data would be skewed to the left. And it's by drawing our histograms that we can figure out, is our data normal, uniform, or something else. Quite often when grading my algebra classes and other classes, I'll get not a normal distribution, which is what I would like, but what I call a bathtub distribution, kind of the inverse of this. So it's kind of upside down. You get a lot of people here, a lot of people here, and not so many people in between. So a lot of people who don't know it, a lot of people who do know it, and not so many that are kind of in between. But let's let the data show us what we got. So the data we're going to use comes from Triola, and we've already put that in Google Sheets. So you open up your Excel file or your CSV file and import it into Google Sheets. Let's see if we can't figure out a couple quick details about this. One of the things that we might want to know is what the minimum value of our data is. So if you click on a cell here, in fact, let me just type in a few words: minimum, maximum, max. What else do we want to know? Want to know the average? Sure, that's going ahead a little bit. And the count. So if I want to know the minimum, or if you want to know anything, you're going to first type in an equal sign and then type in the name of the command. So let's just start typing. You start seeing it right away, minimum. Type in a left parenthesis, and it's going to ask you, okay, where do I want the minimum of? What values do I want? Now, there's a couple ways you can tell Excel or Google Sheets where you want the minimum from. I can click this, and it's going to give me the minimum of all the data in column A. Put a right parenthesis there, and when you're ready, press the Enter key. And that's one way to get minimum from your data. So let me kind of repeat that, and I'll do it with maximum. It works the same way. Type in equals, and then type the name of your command. So maximum or max, a left parenthesis, and then you click the A here that represents your column. Now that's one way. Another way that you could do it is you could just click and drag over all your data. So if I click and drag, then I get this. It tells me I want from A1 colon to A106. Basically all the data all the way down there. So let's type in a right parenthesis next, and then I got the maximum. So temperatures in this data set range from 96.5 to 99.6. Now that's kind of a brute force approach to finding the minimum and maximum. There's other things we can do, and I'm a little bit torn. I don't want to try and make this class about Google Sheets or any medium. This class is about trying to learn statistics. But a nice little clever thing you can do here is give this column a name. So let me click column A, and then go to data, and let's go down to named ranges. And just give this a really simple name. Emphasis on simple, because this is what you're going to be typing quite often. So let's type in temps. T-E-M-P-S. I don't want it capitalized. I'm not sure that it makes a difference. Type in temps, and now anytime I want this column of data, I can just type in the word temps instead. So let's go down to the next one here, average. Type in the equals, like always, and then average. And you can have Google finish it off for you if you'd like. Puts in the left parenthesis. This time, instead of clicking column A or clicking and dragging, let's just type in temps. So now it gives me the temperature of all these, or the average temperature of all these. Now look what we see there. It's not 98.6, is it? It's different. 98.2 is what we get from this data set. The count just tells you how many observations you have in your data set. So type equals and then count. And again, let's just type in temps. Now, with this one, you could easily just scroll down and see, but it tells you what we saw anyways. There's 106 pieces of information in this data set. Now, what I want to do is I want to generate a frequency table and then a frequency histogram. So let's look at this. I typed in these numbers ahead of time just so that you wouldn't have to go through the pain of watching me type it, because I'm a really poor typist. But I'm going to break up my data into these categories. So I'm going to break it up into 96.5 to 96.9, 97.4 to, or 90.7, 97.0 to 97.4, etc. Basically, little intervals of a class width of 0.5. So, with all those, this is just kind of the names of my intervals. You don't need to type this in at all. What we'll need is the class boundaries. And that's what we're going to put over here. So I'll start my class boundary at 96.9. And that's what you should type in one of your columns as well. You don't need the stuff that I have in column H, or in column F, but you do need it in column H. And then I'm going to increase by 0.5. So I want 97.4, etc. And I got to keep on adding 0.5. This is getting repetitive. So here's a little finesse for you. You don't have to learn all these finesse tricks. But if I type an equals key and click this cell and just type in plus 0.5, it's going to take whatever I have in that previous cell and add 0.5. And now I'm getting clever. I'm going to copy this and paste it into the remaining cells here. So it just fills it out. It keeps on adding the 0.5 for me. So a little trick. Look, it's pretty easy to do it manually if you needed or wanted to. Certainly what I don't want is I don't want to have to go through this by hand and figure out, well, gee, how many were there that were less than 96.9? How many there were between 97.0 and 97.4? That would be a drag. That'd be a real waste of time. We're going to get our calculators to do this. We're going to get Google Sheets to do this. So let's type in equals key. Now I want frequency. Frequency distribution. There's two things I need. I need to know where the data is. And the data is in temps. That's my data. And then it needs to know the classes. It needs to know what are your class boundaries. Where are the dividing lines for one of these versus the other? Now, if you're motivated, you could put in a name for this, like boundaries or bins, I think would be an analogous name that you would use in Excel. Or you could just click and drag. So here's my boundaries. So you click on this column, drag, and highlight it, and that should give you your frequency distribution once I press the Enter key. So the first one is where your data is, the second one is where your class boundaries are. And there you go. There's your frequency distribution. Nice. Now, one thing to understand is, well, what's happening is, where does 96.9 go? Would that be in this class or this class? So I'll tell you what, to figure that out, let's sort this data and take a look, and we'll do a little live experiment. So if I click on this data set, one of the options would be to sort it. And let's sort from A to Z. Hoping this will do what. Let me undo that. I'm going to do it this way. Let's see, data, sort. Sort column A from A to Z. So from lowest to highest is what that's doing. So I sorted this column, and I can see that I've got two pieces of data in this class, right? 96.5 and 96.9. What do you think would happen if I made that, instead of 96.9, what if I made it 96.1? What would that change? Is that going to go into the next class, or is the cut point, is that boundary, you think, at 96.95? Let's find out. Let's make that 96.91 and watch what happens to the frequencies. Moved into the next class. So that 96.9 is your class boundary, and everything that's less than or equal to that is going to go in that first class. So let's go back here and make that 96.9 again, and it goes back into this class. Now what I really wanted here was a frequency histogram. I want a nice chart of my data. I want to be able to see it and look at it. We need to decide, is this a normal distribution? Is it uniform? What do you think? Does it look like it might be a normal distribution? Well, it looks like you get a big pile up here in the center, trailing off to either side, so it looks like it could be normal. Yeah, maybe skewed a little bit. Let's take a look at it by doing a chart. So click Insert, and then go down to Chart. So Insert, Insert, and then Chart. Now it's giving us a recommendation, but we should probably, yes? If we highlight the data ahead of time, then it'll give you a little bit more of a recommendation. So if I wanted to highlight column A, and then I went back, then it's going to give me a little bit more of a recommendation. So back, Insert, Chart. And one of the recommendations is a histogram. You can click that right away. I'm not sure this is exactly what I would want, but let's just click it, and then you can insert it. So that's one way to get your histogram. Probably want to play around with this a little bit. Does it look normal? Not exactly. Not the way it is here. But let's play around with this a little bit, see if we can't create a better chart. So I'm going to go back up here and delete this chart, see if we can't create a different one. So let's go into Insert, and then Chart. This time I'm going to go to Chart Types, and there's a lot of different chart types that you can pick. Let's see, let's pick this one. Let's see, do I want that? that's not the one I want. Bar chart, scatter. Stack column. I don't want to use column F as labels yet. Rats. How come this looks different now than when I did it at home? I think it's... Let's click this. Let's delete that. It's going to ask you what's the range of your data. So I'm going to select column A and then add another range, which would be column H. So the one is our data, the other one's our cut points. And now let's go down. No, it's still not doing it. What's wrong? Oh, we're going to use... All right, we got to use one of these columns as a label, and it wants to use column A as a label. Let me see if I change the order on these. If it uses the right one as a label. No, it's still with column A as a label. All right. Let me try this one last time. Insert chart. Where did I... Start by search. There. Add another range. Column A. Man, I'm sorry. I thought I had this one down. Boy, what's that? No, the thing that I want to do is kind of customize our chart. I mean, the initial histogram we had was okay, but I want to be able to customize it to show or to specify how wide the class intervals are and where they start. And it's just not working for me here. This is pretty frustrating. Well, yeah, the customization, but I need to get the columns and stuff like that right first. So, all right, one last time. Chart. No, I don't want recommendations. No, it wants a range. It's not going to let me use my named data here. So H. And in the range, A. No. Try the other order. Chart. At a range, H. Chart types. Okay. This isn't happening for us. No, it's not working. Why isn't this working? All right, I'm missing some kind of a step here. Let's take a look at the data in StatDisk. I know that you guys have this open in someplace else, but but I do want to take a look at the data and draw some conclusions for it. In StatDisk, you can go down to histogram, like we did before. User-defined widths. Let's do 0.5 for the width. Class start at 96.5. And plot. So this is using StatDisk. It is kind of friendly, but unfortunately, I don't think StatDisk works the same way on Mac as it does PC, and I'm not sure if it works on tablets. Let's take a look at our data, though. The important thing here to see is whether or not this looks like a normal distribution. What do you think? What are you seeing? Is that a nice bell shape? It could be. It's kind of hard to tell. It's a little bit subjective at this point. We don't have any means by which we can objectively identify whether or not something is or is not a normal distribution. It kind of looks like it could be normal, but we're not sure. What changes that, and what can change this a lot, is things like the class width. What if I did the class width of, say, 0.3? Oops. Don't send. I don't need to type in the notes. There we go. 0.3. Or 0.2. Now what do you think? It changes the look a lot, doesn't it? The thing that you have to be careful of when you're creating your frequency classes is not to use too many and not to use too few. Because if you use too few, then your data is going to be all lumped together. So if I did a class width of 1, all our data is lumped together. If I do a class width of 0.2, it's too far spread out. You're not summarizing things enough. So you have to choose something that's a nice happy medium. Right now, with what we have available, it's tough to say whether or not this is a normal distribution. But eventually we'll get a quick test to help us decide whether or not it is or is not a normal distribution. Let's look at some of the problems in the book that start getting at some of the issues you're going to face when you start creating your own frequency histograms. And that is the class width. How wide do you want these things to be? So moving over to here. Problem number 6 asks us to figure out, well, what's the class width here? So it's kind of tough to see looking at this, but the class width looks like it goes from 45 to something here, and then up to 50. Let's zoom in a little bit more if we can. How many intervals are there between 45 and 50? How many bars do I have?
6.
Between 40. Yeah, about 2.5. Or how about if we go between 45 and 55? About 4 then, right? So we have a width of 10 divided by 4. So it's going to be 5? Yeah, there we go, 5. So it's going to be 2 inches per interval. So that's your class width here. Now this data kind of gives us something as a side benefit. This represents the heights of people visiting a museum, New York City Museum of Natural History, during a recent Friday morning. Now you have a big cluster of data here and another cluster of data here. What do you think could explain the 2 different peaks? Yeah, children and adults. You have a lot of classes, you know, grade school classes visiting here with, you know, some smaller heights, and then you got their chaperones. And their chaperones aren't going to be as numerous, but they're going to be taller. And that's what you're seeing here is a collection of taller data. We already graphed the last digit data, so let me skip down to another one. Problem number 12. Let's see if I can't zoom in a little bit on the actual histogram. So you don't have this for your cells yet, but this is the histogram of data from one of the previous exercises in section 2.2 for the pulse rates of healthy females. Does this data look like it might be a normally distributed data set? Yeah, a little bit skewed to the right. I mean, if you close one eye, and then close the other eye, and then close both eyes, then yeah, it's normal. How about the one down below here? Frequency of earthquake, or the depths of earthquakes. Is that a normal distribution? This one should be pretty clear. This one's clearly not a normally distributed set of data. Okay.